Hi, I'm Danny Wright and I'm the event manager at SARSEF, and I am so thankful that each of you are tuning in for Arizona STEM Adventure. I hope you're having fun and I hope you're learning a lot. Okay, for this activity, you will need paper clips. That's it. What we're gonna do is unfold the paper clip. Try to get it as straight as possible. All right. Something I discovered about paper clips this week as I was helping to create your kits is I learned this shape of paper clip is called a trombone paper clip. All right. I got it nice and straight. Okay, so the next part of this activity is you are going to hold it really tight at the end. Really tight at the end. Once you have your paper clip straight, what you're going to do is, with one hand, pinch just the very edge of that paper clip. Now, on the other side, either you, or if you're able to be close to someone and do this activity with someone, either a grown-up or a sibling who you might be able to be close distances with, they are able to have access to just that last few millimeters of that paper clip, and their job is to try to rotate it. All right, how was that? Is that easy for it to rotate? Is that difficult to rotate? What was your experience there? Okay, next assignment. We'll take our paper clip, and this time you're going to make two bends in it. All right, so it kind of looks like an S a little bit. Or almost a Z if you made it further, but you're making two right angles in it. Just like that. Okay, now we're going to do the same thing. You're going to hold the very end of it, and then someone gets access, or it can just be you, to just the last little bit and see if you can rotate it now. Wow, how is that different? Was that easier or harder? Make sure you get an opportunity to do both sides. Make sure you have an opportunity to hold this and also an opportunity to try the other side. Now, do it a few more times with the rest of your paper clips and see what happens if you make bends in different places in your paper clips. See how that makes a difference. What do you think's happening here? Why is it easier to go when it's bent as opposed to it's straight? And why would it be easier with having the bends in the different areas? What do you think's going on? All right, did you get a chance to work with your paper clips? Now, what was happening here? Why was it so much easier to rotate it when it was bent as opposed to when it was straight? Okay, what we've created is a simple machine. You maybe have learned about simple machines, right? Levers, pulleys, and a wheel and axle, or a crank. Where do we see cranks in the world? Well, I was thinking it could be like a fishing reel, right? We see that. Cast it out and then reel it back in, right? We see cranks on old pencil sharpeners. Have you ever used one of those pencil sharpeners where you have to crank it to sharpen the pencil? Another one, how they used to start old cars. You'd have to crank it to get the engine to turn over, right? And all of those things make it easier than just spinning. If you had to just spin that little thing when you cast it out, and instead of having a crank to reel it in, if you had to just try to spin that and reel in that fishing line, that would be a lot more difficult. So what's happening here is, since we have this axle that goes in, when we apply torque, which is this rotating movement, this can rotate a lot faster because on the outside we create more force as we're rotating the bigger rotation on the outside. It then can spin faster on the inside. So applying that torque makes it run more efficiently. Great job.